this is Algebra 2, Section 9.2. We're putting our angles into the Cartesian plane. All right, so we remember what the Cartesian plane looks like. Okay, we have an x-axis and we have a y-axis, and they go on and on into eternity. All right, and we need to remember that my first quadrant is here. We're going over here for the second, down here for the third, and over here for the fourth. So it goes in a counterclockwise direction, okay? It's going to be important to note that right and up are positive, left and down are negative. Okay, so you have some definitions there on page 420. It talks about putting an angle in here, and it talks about the initial side, means that's where I start. Initial means beginning. Okay, so let's try it. I don't know if we can make a different color show up here. Okay, so there's my initial side. All right, so I've got this line, and I'm going to rotate it until I get to where I want to go. So let's say we want to put a 30-degree angle in here. We're rotating until we have gone 30 degrees, and then we're going to draw our terminal side. Okay, if you have a terminal disease, it's probably going to end in death. We all have the terminal disease of sin, and it's appointed that the man wants to die. Okay, so initial is the beginning, terminal is the ending. Okay, and notice I've shown which direction I'm going, and I'm going to say I drew a 30-degree angle. Now, I can go the other way as well, but if I go this direction, it's going to be in a negative direction. So if I decide to go 20 degrees this way, then here's my initial side still on the x-axis, but my terminal side will be down here, and so that is a negative 20-degree angle. So positive goes up and over in a counterclockwise, negative goes down and around in a clockwise direction. Okay, always draw your angle, mark your angle degrees. Initial is the beginning, terminal is the ending. Okay, we always start on the positive x-axis. If we do that, it's said to be in standard position. It must start on the positive x-axis, not over here, but over here, and rotate to the terminal side, and it will be in standard position. Okay, so in your first section here in 9.2, you're going to do a lot of drawing. I've enclosed little bitty graph paper. Okay, get a straight edge and draw small, very small Cartesian planes. Okay, you need a separate one for each problem. Don't make them any bigger than they have to be. Unless you have your own graph paper at home and you have an endless supply, then make them as big as you want. But you need to try to fit them all on there. It would be helpful to me if you put your Cartesian plane, say in pencil, and use ink for your graph, or something that makes it stand out from the other part, so I can see, like here, that the initial side is on the x-axis. All right, now what if I want to draw a 90-degree angle? Then I've come up here, let's go here, and I've started at my initial side. I have to draw it in, and we're coming up here 90 degrees, and look what happens. I actually end up on the y-axis. That's a 90-degree angle. Or I might draw a 180-degree angle. I'll end up on the x-axis again. Or I may even draw a 270-degree angle, which again ends on the y-axis, or possibly even a 360-degree angle. That made a whole circle, okay? And that ends back on the x-axis. So anytime my terminal side lands on an axis, that's called a quadrantal angle, okay? That's written in your book. It's almost like a quadrantal if you're really looking at the spelling. So make sure you learn how to spell it right. Okay, quadrantal angles end on the axes. Okay, if you look on page 422, Because we are going to be putting triangles in these on the Cartesian plane, we're kind of going to redefine some things. Remember, this is the x-axis, and this is the y-axis. And if I draw a triangle in here, okay, then this leg is going to fall on the x-axis. This leg follows the y-axis, it's vertical. And if we consider the fact that basically we're drawing one big circle, this is the radius r. Okay, now because this is always going to be the angle of focus, this is going to be my reference angle, theta. Can't remember if we talked about theta or not. I know I've typed it into your notes, so I don't remember if this is new or if it was last week. Theta is a Greek letter, and that's going to be our reference angle. So when we set it in here, theta is always going to be right here at the intersection of the axes at 0, 0. All right, we're going to have the initial side. We're going to draw around till we come to the terminal side, and then we're going to complete our triangle toward the x-axis always. We're never going to draw our triangle towards the y. Okay? Now, if this is theta, what we learned before is that the side across the triangle is the opposite. The side next to it is the adjacent. And of course, this is the hypotenuse. All right, so we're just redefining. So from now on, when I talk about sine, instead of calling it opposite over hypotenuse, now I shouldn't have said from now on, but in this particular section, okay, instead of referring to the opposite over the hypotenuse, I'm actually talking about y over r. Nothing's really changed. It's still the same ratio, but this is important. Now, because this is a radius of a circle, it always will be positive. It's a length, okay? It has to be a positive. Here, however, in the first quadrant, x is positive and y is positive. Later, we're going to find as we get over here that that can change. Okay, the same thing would happen with cosine, and this is all in the table on page 422. So the example has us look, and you're going to be doing quite a few of these till you get a hang of it. Okay, again, we're really only working with the first quadrant here in the beginning. And it says, suppose I have a line passing through the point 3, 4. That means I'm starting here and I'm drawing up to 3, 4. That means I've counted over this direction 3 and up here 4. We're forming the triangle by drawing to the x-axis. Theta, my reference angle, is always here at 0, 0. This is going to be my radius. This side follows the x-axis, and this follows the y-axis. So x in this case is 3, and y is equal to 4. How are we going to find r? We're going to use the Pythagorean Theorem. So r squared is equal to 3 squared plus 4 squared, or r squared equal 9 plus 16, r squared equal 25, or r is equal to 5. Now I can proceed, like they have at the bottom of page 422, to find the sine, the cosine, and the tangent of this triangle with this reference angle. So the sine will be the opposite over the hypotenuse, or y over r, which is 4/5. The cosine will be the adjacent over the hypotenuse, or x over r, which is 3/5. And the tangent will be opposite over adjacent, or y over x, which is 4/3. Okay? And that is it for this particular section. Follow that closely as you do your work. Thank you.